Hello and welcome to C++ Weekly. I'm your host, Jason Turner. Just a friendly reminder that yes, I am still available for code reviews and on-site training. And now would be a spectacular time to contact me. In this episode, I'm going to revisit a topic that I've touched on once or twice before about analyzing build times. We're going to be revisiting ftime-trace from Clang and looking at some other tools that I didn't mention previously. So be sure to stick around for this one. This week's episode is sponsored by HRT. If you've attended any C++ conferences this year, there's a good chance you've already heard of HRT, as they have sponsored several conferences. HRT is known for its deep engineering culture and strong focus on performance. And they are looking to hire the sharpest engineers to help them to develop and optimize the technology at the core of their business. They're headquartered in New York, but they have offices in Austin, Chicago, Boulder, London, Dublin, and across Asia. They're looking primarily for C++ and Python developers. I know, since you're a viewer of C++ Weekly, you are a C++ programmer, and you probably already program in Python too. So go ahead and check out the link on the screen for openings that they have. And remember, you don't need a financial background, just strong engineering fundamentals, and they'll teach you the rest of what you need to know. I'm going to do a very quick demonstration with my ConsExpert scripting engine. We're going to just use the latest version of Clang that I have installed, which is 21 here. And I'm going to put this thing in C++ 23 mode and very simply just build a very simple, minimal test program that doesn't require any other dependencies of any sort. Okay, let this be a quick lesson to you to remember that if a project is not being tested by your CI, well, this one particular executable is not being tested by the CI, it broke when my API changed. Well, that's on me. The point of this is -ftime-trace. There we go. I compiled the thing and I got a time trace file. a-main_minimal.json. It's that file right there. So I demonstrated before that you can open this JSON file directly in Chromium. But there's a Speedscope website that seems to be fairly well regarded, and we're going to go ahead and play with this for this episode. And I have never used this before, so we'll see how it goes. This is the file we we're just talking about. All right, very good. We have the Speedscope. This is the exact same information that we would have seen if we had been using the one built into Chromium. But we can see where the time is spent. Parse, declaration, or function definition. So all the compile time seems to have been sent. Let's see, instantiate function of, so parsing of this declaration at line 5, evaluate, that's the evaluate function, and instantiate function goes to the ConsExpert constructor, which makes a lot of sense because the ConsExpert constructor is const_eval, so it's going to be doing all of that work at compile time. And we can look and see that the eval function is one of the main things that's taking most of the time inside here. All right, so this is a way to browse this. And I'm just doing an overview of the fact that these tools exist. I'm not here to show you how to actually dig into all of this, but you can look and see where the front end is the thing spending most of the time, and the back end is spending less time. Let's go ahead and make an optimized build of it. Let's go ahead and reload this file. And remember, the last build that we did was an optimized build, so we should see more of the time spent on the back end than the front end. And that is in fact what we see. The optimizer is what takes the most time now. That's all good, but that's only part of what I wanted to show you. The main thing that I wanted to show you is the ability to do this on a larger project. So we've got this Energy Plus project that I have talked about before. It's something that I used to work on. And I have configured CMake to have a time trace build. So it is going to be automatically doing all of this time trace stuff for us. But we're going to use this in conjunction with another tool called ClangBuildAnalyzer. There we go. I have a local build of ClangBuildAnalyzer. Let's go ahead and pull up the official docs here on GitHub. Usage, start the build capture. So we want to do ClangBuildAnalyzer -- start some artifacts folder. And then we want to do the build, and then we want to do stop. Okay, so we're going to run ClangBuildAnalyzer -- start, and I'm giving it the current directory because I'm going to expect all of those JSON files to be generated here in this build folder. Then I'm going to go ahead and I'm going to do a full build of the system. Okay, we've gotten a couple of build errors, and I guess somewhat in my defense, I haven't tried to build this project recently with a very recent version of Clang. But that's okay. Let's see what information it was able to generate for us. We do the build, which generated a bunch of these JSON files, and then I'm going to generate this capture file here. And hopefully it will find all of these files in the artifacts file that were modified after the start step was done. So you don't have to worry about stale JSON files necessarily. All right, and then it advises us to run analyze on the build report file. And this is where things get interesting, and this is meant to be the point of this particular video. So files that took the longest time to parse. Now, it didn't get into the meat of this project, but that's fine. I can see in libkiva that instance.cpp took 8 seconds to parse, and that kind of does sound like a long time, in fact. In fact, we can see that 318 seconds were spent in parsing and 145 seconds were spent in the backend. Now this build I do not believe is doing link time optimization, so this should be pretty legitimate numbers. Interestingly, SQLite does show up as one of the longer files to parse, and it shows up as the longest file to compile. Now, granted, SQLite is written in C, it's going to parse much faster than the C++ code. Templates that took the longest to instantiate. This is where things are going to get very interesting for those of you who are trying to optimize your build. If you see that 95 times the map of fenestration materials had to be instantiated, this might be a clue to you that perhaps this is some sort of, well, that's a type, it's not a function. I was going to say maybe you could extern template it, but I don't think so. But might be something to be worth considering. And these, well, these RB trees are part of the top thing being instantiated here. That's part of the map implementation. So you're not going to be able to do a whole lot with that. Interestingly, basic string is showing up as 181 times of instantiation, which modules would help a lot with if modules were a thing that we could consistently use. There's a lot of these template map things that are inside of our standard library that are really showing up here, and it would be great if we could do standard modules. Functions that take the longest to compile. So this is the point of this, is ClangBuildAnalyzer. You're gonna wanna take a look at this, and it's pretty easy to set up, actually. You just need to pass ftime-trace with Clang during your build to generate these JSON files, and then you can go and dig in to individual files if you want to with one of those flame graphs, and also use ClangBuildAnalyzer to aggregate all of these things for you. Wow. This WinCalc engine header file got parsed 95 times, and that's because the build stopped, it probably would have gotten parsed a lot more than that. That's 51 seconds spent on that directly. It sounds like that would be a pretty good candidate for a precompiled header if you can't move to modules, because this is in a third-party library and it should effectively never be changing. So that would be something to consider. Standard string, anything in the standard library becomes a good candidate for precompiled headers. Hopefully this gives you some more tools in your toolbox to look at. Now note that this is configurable with an INI file, does not capture anything related to linking or LTO, might not scale to huge builds, whatever. All right, check it out. ClangBuildAnalyzer, ftime-trace, and speed scope. I hope this episode of C++ Weekly was at least a little bit insightful and interesting. You know, hopefully you're able to optimize your build a little bit. Go ahead and leave a comment if you do manage to optimize your build. Otherwise, thank you for watching this episode of C++ Weekly. I'll catch you next week.